So we're starting our section 3.2 on the spread of data distributions. In this section we're going to compute the average or the range of a data set. We're going to compute the variance of a population in a sample. We're going to compute the standard deviation of a population in a sample. Actually, we're going to spend more time on the sample, because technically we usually don't have the information for the population. So our first objective is to find the range of a data set. The range is the difference between the maximum and the minimum values in the data set. The range shows the span of values within the data set and allows the researcher to use this information for tables and graphs, like we've done in the past with our histogram. To find the range, the data set is sorted in increasing value and the minimum and maximum values are identified. The actual range value is the maximum minus the min. So in the next example, the average monthly temperatures in degrees in Fahrenheit for San Francisco are the following. There are 12 months in which the average monthly temperatures were taken for a particular year. The maximum temperature was found in September at 63. And the minimum temperature was found in January at 51. So to find the range, we just take 63 minus 51, and we get a span of 12 degrees over the 12 months. Interesting. The second kind of measure in measuring spread is when we have a data set like San Francisco temperatures, the spread values are really close to the mean. And so when the data has a larger amount of spread, more data values will be farther from the mean. The variance is a measure of how far the data's different individual data are from the mean. And so we're trying to compute the average difference from the mean, and we call that, eventually we'll be calling that standard deviation. But the first step is finding what we call the variance. So a deviation is the difference between the observation's value and the mean value. So a deviation is x minus x bar for the sample. It's x minus mu for the population. These are called deviations. When we sum up the deviations for a data set, the sum is close to 0. So the sum of the deviations is not a good measure of spread. So statisticians came up with the idea that to measure the spread from the data set, an average spread from the mean would be ideal. So the idea was to square the deviations for each observation and add these squared deviations and divide by the number of observations. So here is the variation for the population. Notice that the value is a squared value. It is a squared value. And initially, this will give us a big value for spread. So we really ultimately will want to take the square root of these values to get the average distance from the mean. So you notice that there's a difference between the population and the sample. For the population, it's just divided by n, the total number of observations. But for the sample, it's n minus 1. And the reason that it is n minus 1 is because of what we call something noted as the degrees of freedom. In a data set, we have initially n degrees of freedom. But when we calculate the mean value now kind of sets the data set in stone. So anytime we subtract a value from the mean, since it's its center, it's now no longer free to roam, so to speak. So that's why they call it the degrees of freedom. So because we calculate x bar from the sample, it should not be included in the data set. So that's the reason we call it the unbiased estimate. So here's an example of finding the variance in the standard deviation. A company manufactures batteries, is testing a new type of battery design for a laptop computer. They measure the lifetimes in hours of 6 batteries, and the results are the following. So there is our variable x. X equals hours of lifetime of batteries. Okay, and so we can now sum those up and get an average. So we can add those up, get an average, and then we can calculate what we call a deviation for each value. So for the value of 3, it has a -1 deviation from the mean. For the value of 4, well, guess what? 4 was my average, right? So x bar is equal to 4 in this case. So 4 minus 4 is 0, right? For 6, the deviation is 2. For 5, the deviation is 1. For 4, again, it's 0. And for 2, it's -2. It's 2 below the mean. So when we sum up the deviations, you will notice it is 0, right? Which is not very useful for measuring spread. So what we do is we then take the deviations and we square them. And when we square them, we get the following numbers. And when we add them together, when we add up all the deviations together, we get 10, right? And so for the sample, the variance is 10 minus 6 minus 1, because n is 6, and then minus 1 is unbiased. So the variance is 2. But this is s squared. It is squared, so we have to take the square root to get the average spread. The average spread from the mean. So the average spread from the mean is called standard deviation, and we just take the square root of variance. And in this case, when we took the square root of 2, we got 1.414 hours. So the major idea on spreads of distributions: for quantitative data, the average spread of the variable from its mean is called the standard deviation. Standard deviation, right? And that's going to be the measure that we're going to use primarily for spread of quantitative variables. The standard deviation is the square root of the variance. Make sure you understand that piece of information. The researcher is interested in understanding the span of values of the variable in relationship to the data's center. The standard deviation provides the best measure for researchers to find potentially extreme values, which we're going to eventually call outliers. The major problem with standard deviation is that it's influenced by extreme values of the variable. We will see in the next section how to improve and identify extreme values from a data set using non-parametric statistics. Alrighty, so that's the end of this chapter, and we will be discussing a little bit more of this chapter in just a second. This is part 1 of 3.2.